All right, this one is going to be for 6.3. So this is the math lab. I'm just putting the day on it just to kind of differentiate it from the other ones because I know I've done a couple of these bad boys. 6.3, we have two questions. One is 1B. This is a quick one from page 468. And this one, the question is, it says to the nearest degree measure angle C for each triangle. For this part, it's wanting you to actually physically measure. If it says calculate or find, that's when it wants you to use trig and plug numbers into the calculator and things like that. In this case, it actually wants you to measure. Hands-on to ideally kind of help the material sink in. So I think that's all the only question that was regarding that. The second part is page 469, number 4. This one says in triangle ABC, I'm just going to draw it. Triangle ABC. What angle? Okay, so this will be angle A, angle B, angle C, lel A, oops, lel A, lel B, lel C. AB is 10, AB is 10. Oh, okay. I recorded a lesson for 6.4 earlier today, and in it I said I drew a triangle and I said I was kind of hoping I would have drawn it wrong because I would have changed it to show you. I drew this one wrong, and I'll show you the change that I need and want to make. Because this question is talking about, it looks like ambiguous situations. So I'll just complete this the way I drew it for now. So AB is 10, AB is 10, BC is 8, BC is 8, and to nearest degree determine measures of A for each situation. Okay, we need to solve for A. I don't like these here. I want these two sides. Those are the ones that we want to know. This is not going to help me. So I'm going to, actually I'm not going to redraw this, I'm just going to scribble it out because I want to use this space. So I'm going to switch, this is going to be C, this is going to be B. So 8 is going to stay, but C is going to go over here, and this will be little b. Now the reason I did this is because I want to be able to swing this as if this was on a hinge, and this side, I want to be able to swing it. I want to be able to visualize that so I can see these different possible scenarios. Now, when I glance at this, it's kind of not fair because you guys are having to figure this out as you go. But I can see this is setting us up to figure out ambiguous cases. So even before I know what each question is asking, I want to know what the height is here. Maybe I'll do that in a different color. And I'll tell you why in a couple seconds. Oh, the angle A, we don't have angle A, so I can't figure out that height yet. Okay, I guess this is the point where I should probably read the question. Angle, okay, now it says determine the possible measures of angle A for each situation. No triangle is possible. So what that means, for no triangle to be possible, so this is part A, what that means is this side would not be able to reach the ground, basically. So the height needs to be greater than 8. Does that make sense? Because if this height was 8.1, this side wouldn't reach. It wouldn't be able to reach the ground. Even if it was straight down, this is 8, but then the height is actually 8.1. So what we're going to do for this is we're going to assume this opposite side is 8.1, just to pick an arbitrary number bigger, and then solve for the angle. Another way we can do it, which is probably better, is figure out what this is for 8. If this was 8, and then the angle A would be anything bigger than that. So what I mean, is imagine we have this right angle triangle. Hypotenuse is 10, opposite side is 8. Now we've got to solve for this angle. Okay? So sine of theta equals opposite over hypotenuse. That's 8 over 10. Theta equals the inverse sine of 8 over 10, which is 0.8. So 8 divided by 10 is 0.8, and then we're going to second sine that. So it's 53 degrees, 53.13 if we want to get real specific. Theta equals 53.1 degrees. So what that means, so the question says, to the nearest degree, determine possible measures of theta for each situation. So in this case, if angle A, to the nearest degree, so if angle A is 53 degrees, this side is 8. So for there to be, what part A is asking, for there to be no possible triangles, that is what happens if angle A is greater than 53 degrees. Because it's 53, right? Like it's, as if this is 53. It's actually probably pretty close. But if this is 53 degrees, as soon as you make it a little bit bigger, 54, 55, blah, 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 blah. As soon as you make it a little bit bigger, imagine this side is kind of hanging down where that dotted line is. It's lifting it further away. So that makes the triangle impossible. So your answer to A is, when it says possible measures of A for each situation, angle A would be greater than 53 degrees. Or you could say, because it wants it to the nearest angle, angle A is greater than or equal to 54 degrees. Cool, cool, cool. So now, for part B, it says when one right triangle is possible. Well, we figured that out. That's 53 degrees. That would be, this is one situation. That 8, this side, can't move either way, otherwise it's not going to touch. Okay, so that part B is just 53 degrees. Now, because I don't want to do the whole question for you, for part C, it's saying 2 scalene triangles. So in other words, 2 possible triangles. This would be an ambiguous case, which is what today's earlier lesson was about. So I'm not going to do that one for you. I want you to play with it. I want you to mess with that and see what you come up with. Well, I'll tell you, though, it's definitely going to be less than 53 degrees. How much less? It's up to you. All right. Anyway, good luck. Let me know.